Hello, everybody. Welcome to CogX Day 3. And we are just about to have a very interesting discussion on digitalization and AI in the green transition. We're going to start off with a keynote from Dan Jeavons, who's the VP of Digitalisation and Computational Science at Shell as part of the Planet and Smart Cities track. Dan, handing over to you.
Perfect. Well, look, thank you so much for having me. It's an absolute delight to be back at CogX, and it's great to be taking part in a hybrid event and to be here in person. I'm also absolutely delighted that I'm joined by Bernard Marr. Bernard and I did this little conversation around AI and energy a couple of years ago now at CogX, and I'm really excited to be reprising that conversation and, if you like, updating it as we look at the challenges that we face in the energy sector. And I think it couldn't be more apt that today the theme of CogX is around getting the next 10 years right. And the reason I think that is such an exciting theme is that it's never more true that we need to get the next 10 years right than in the energy sector. I think it can't have escaped any of our notice that the climate challenge is real, and coming out of the COVID pandemic, the focus on solving some of the challenges that we have in the energy sector and the broader industrial sector couldn't be more in focus. To put that in context, at present, the global emissions are about 51 billion tons of CO2 per annum. And when we stopped flying during the COVID pandemic and more or less stopped driving during 2020, we saw those emissions levels drop by around 6%. And I think that puts in stark focus the challenge that faces all of us to truly transform the energy sector, and the growing sense of urgency that those of us working in the sector feel to try to accelerate the pace of change. And I think it couldn't be more abundantly clear that part of the solution to this problem, as well as behavioral change, has to be technological innovation. We recognize that although there are going to be many aspects to solving this problem, which is going to involve collaboration of all parts of society, technology innovation is going to be a key part of driving the innovation and the change in the fundamental systems that power our society today. And that's going to be necessary to achieve some of the net zero targets that we've set out. Within that, I also want to focus on the role of digital technology. And for me, it's very, very clear that we can't argue that digital technology is going to solve energy transition. However, I do believe that digital technology has a very, very key role to play in helping accelerate the global pathway to net zero. And during the rest of this talk, I'm going to try and unpack a little bit of why I think digital technology is so important. But really, it has three key roles to play. Digital technology is helping us to design new energy and industrial processes that ultimately are going to operate with much lower CO2 footprints. Digital technology is also going to help us to optimize the existing energy system and to reduce its emissions. And perhaps most importantly, it's going to help us to track the global footprint and also to monitor and create transparency around the emissions that we all generate and the footprints that we're all responsible for. So why do I have such faith in digital technology? I think the key point is right now in the digital domain, we see the convergence of digital technology like never before, which is further accelerating digital change. And in particular, I see that happening in four key areas. Sensor data is being generated all around us all the time, whether that be through smart devices in your home or an increasing amount of sensors within our industrial facilities. All of that data can now be aggregated in near real time in the cloud and made accessible in such a way that massive queries on full history of data can be run relatively easily on commodity hardware. Alongside that, we see the emergence of digital twin technology, which is starting to leverage technology from games and also from artificial reality and virtual reality, where effectively we are bringing together all of the data in context to create a digital representation of the physical asset. And that the combination of the, if you like, virtual reality aspect in conjunction with the real data provides a true opportunity for AI, where we can start to simulate and look at exceptions and create unknown conditions, and as a result to start to optimize much more effectively the overall operations of a particular industrial facility. And finally, when you combine that with distributed ledger technology through blockchain, you start to be able to create tracking across organizational boundaries in such a way that you can create the level of transparency that I believe is going to be needed in order to accelerate the sort of energy transition that I've outlined. So I see that convergence of technology as being absolutely fundamental. But what I also want to do is talk about some tangible examples of things that are already happening that point us in this direction. Over the past few years, we have been aggregating already our vast quantity of sensor data into an aggregated cloud environment that's now running at the multi-trillion row scale. And we're using that to develop a whole series of new capabilities within Shell. One example is that we're applying this to our traditional oil and gas processes, and we've already seen the impact of that. For example, within our LNG business, the deployment of one of these algorithms on an LNG train has demonstrated that we can reduce the CO2 footprint of that train by about 130 kilotons per annum through reduced flaring. And that gives, for example, the impact of that is about the equivalent of taking 28,000 vehicles off the road, to put that in perspective. So you see that the deployment of this sort of AI, a single algorithm, can have that sort of impact on CO2 emissions. But it goes beyond that. We can also use these same approaches, this combination of machine learning, data-driven simulation in context, leveraging these vast quantities of data, also in conjunction with physics-based models in order to create new optimization scenarios and to design new processes. And some of you may have seen recently that we were able to develop 500 liters of synthetic kerosene. What that involved was removing CO2 from the air and turning it into sustainable aviation fuel that we use to fly a plane from Amsterdam down to Spain. And I think the key point there is that we're using now the AI technology to help us design and rapidly accelerate the deployment of technology like this at scale and in an affordable way to make these things commercially realizable. And maybe a final example, we're also leveraging all of these capabilities more and more in the power space as we build a power business through virtual power plants and the like. And perhaps never more so than in our electric vehicles, which we see cropping up all over our cities now. And in the number of charge points, 80,000 to date, with access to about 225,000 that Shell is operating. And of course, we have ambitions to grow beyond that to about 500,000 charge points by 2025. And so if you look at all of that, this is in the electric mobility space, we're going to see a rapid acceleration of these capabilities. And of course, all of that new data creates an opportunity for AI. And we're starting to develop that to optimize the charging processes, to ensure that when we plug in, the vehicles are charged in the most energy efficient manner, leveraging the maximum amount of renewables. And we're deploying that technology already to customers in the US today. So I've covered a lot of ground in a very short period of time. Unfortunately, I'd love to talk about this for longer, but maybe just to kind of, in closing, talk about the overall approach. I think we have to recognize that this is a radical change. It's a radical change in culture for an organization like ours. It's also a radical transformation in the energy system and in the infrastructure that we operate all over the world. And so to do that, we have to work differently. And I think most importantly, we have to work together. One of the things that we've been driving in Shell is openness, radical openness at new levels. We've led the industry in what we call the OSDU, which is an open energy data platform designed to allow easy exchange and to avoid proprietary formats. And we recognize that that open data exchange is going to be critical to powering the capabilities that I've described today. We also launched the Open AI Energy Initiative to allow the exchange of IP between major energy providers to accelerate the adoption of AI and in turn to accelerate the embedding of AI in the energy system. And of course, we're trying to also leverage this in the emissions calculation space through our Open Footprint initiative, where we're trying to encourage open standards for the calculation of CO2 footprints. So in closing, I want to close with a degree of hope. I think we all have to recognize that solving the energy problem in a world where the demand for energy is increasing and where energy is part of assuring the quality of life that we all enjoy, we have to recognize that transforming that system is going to take time, it's going to be challenging, and it's going to take collaboration. And it's probably the largest problem that our generation faces. But I also feel that there is hope. I see the level of collaboration growing within the energy industry to embrace the need to change. And I also see the cultural shift that's needed to help to accelerate some of the transformations I've talked about and the adoption of technology that is going to be needed to transform our energy system. So I hope that today I've given you a flavor of what we're trying to do. Bernard and I are going to have a bit of a discussion now. I'm going to also hand over to Bernard because I'd love to hear his perspectives. Bernard's been writing about this area avidly over the last few months. And so Bernard, maybe you want to share a few of your thoughts.
Very good. Hi, Dan. Hi, everyone. So Dan and I have been working together at Shell. We work together on creating AI strategies and data strategies for Shell. And I've worked in this space. As Dan said, we presented two, I think not last one, but the one before together. Last year, I presented on future trends, and I've been talking about, so I've just actually finished a manuscript for a new book called Business Trends in Practice. And for me, one of the most, where I look at some of the biggest trends and biggest challenges, and for me, energy is, as Dan said, one of the biggest challenges the world is facing that we need to address. And it is very clear that our traditional ways of generating energy are too exploitative, they're not sustainable, and they're designed really for a world of the past. And for me, it's no exaggeration to say that I consider transforming the energy sector to be one of the most important challenges we face as the world. And we will achieve this, I believe, by tackling three main issues. The first one is decarbonization. So we need to transition towards clean, carbon-free energy, largely driven by renewables, and then, of course, with it, the electrification of our world. The second thing we need to do is we need decentralization, because this new energy grid will look very different. We'll have more distributed energy production. So instead of this highly centralized grid that we are used to at the moment, energy will be created in lots of different sources and wind farms and lots of renewable generators that will be distributed all across the network. And the third one is digitization. So the use of digital machines, devices, and technology to really to optimize the energy production, the infrastructure, and the use of energy. And I like to talk about this as intelligent energy. And I believe that to realize this vision of smarter, more diverse energy grids, we will need intelligent devices and intelligent technology that helps us to A, communicate with the grid, so demand can be monitored and managed and predicted much better, and B, to help us reduce our energy consumption. So for me, things like artificial intelligence plays a key role in predicting the energy demand and optimizing it. The Internet of Things are key. Another technology that I think has a really important role to play is blockchain, potentially, from secure smart contracts to facilitating distributed networks. And blockchain could be potentially transformative for the energy sector. So maybe I can put this back to you, Dan. How is Shell looking at blockchain, for example, as an enabler in this energy transition?
It's a great example of some of the things that I think we've both been talking about, Bernard. I think blockchain firstly, I think the key for me in blockchain is the fact that the distributed ledger transcends organizational boundaries and creates transparency. And I think that's actually fundamental to solving some of the problems, because half of the issue is often that these systems are often in silos. And the way to optimize the system is actually to transcend the boundaries and start to look across. Let me give a real example. I talked about the example of sustainable aviation fuel, and I talked about how we're using AI in the designs phase. What I didn't say is also, when we think about deployment of that, one of the key areas that we're going to have to address is actually how do you assure that when you provide the fuel, in this case, if you think about something like synthetic kerosene, if you provide that fuel to the airport or to the end customer, indeed, so to your KLM, for example, they're going to want to know that the fuel that you've just given them is sustainable, it's sustainably produced, and they want to know how it's produced, and they want to be able to assure that process. Now, that's deeply complex through a supply chain that you can imagine is going to have other forms of fuel in it in the future. And so what I see is that blockchain is potentially a key aspect of that, where we can say, well, actually, this fuel that we've given to you was actually sustainable. And here's the assurance process, if you like, the certification that gives you the full history of how that fuel was produced throughout the entire supply chain, where it's been, and provides the assurance, and then obviously back to the regulator, that indeed that is sustainable. So that's just one example, I think, of where blockchain is going to be applicable. But I think also what's interesting is that I think blockchain is going to play a more fundamental role in making things more effective and efficient. And the example that I always talk about in this case is something simple like spare part provenance. There's a whole bunch of inefficiency in our supply chains, which obviously has a knock-on on our emissions, which is related just to things being moved around that don't necessarily need to move. And part of that is just because we don't know, we can't assure. So for example, a spare part breaks, we have to ship it back quickly to the manufacturer to get it certified, to then come back, to then be deployed to an industrial facility. All of that creates emissions and waste. And I think the opportunity is for a blockchain to provide the certification there and then, and to make sure paperwork doesn't get lost, and that we know the state of that spare part. And so I think, Bernard, to your point, it's going to have a role in the most fundamental aspects of the supply chain in terms of the energy supply chain, but it's also going to have an impact in very simple areas like spare part management.
Yeah, it's interesting. And do you feel that we've reached the technology that will actually help us do this? Because the challenge with blockchain is also that it has a huge carbon footprint at the moment and huge energy need. I thought it was interesting when Tesla started to accept Bitcoin to pay for their cars, and then they basically say, okay, actually this is going against what we are standing for, because it is so energy it consumes so much energy that this actually negates some of the things we're trying to achieve. So do you feel that there is a solution out there?
I mean, I think, as with all of these technologies, they're getting more efficient all the time. And I certainly think that there are significant improvements, obviously, in the core blockchain technology, which is helping to reduce the computational requirements for some of these things. I also think the crypto is perhaps a bit of an exception because of some of the supply and demand dynamics that are going on there. But I do think fundamentally that people like Energy Web Foundation, for example, are making really good progress in starting to make this sort of technology usable, accessible, and open. And we've certainly been partnering with them in a number of these areas. I also think that we have to recognize that it's a maturing technology. And I think it's going to take time, just like all of these things, and it's going to take collaboration. I actually think the hardest part of using blockchain is actually getting the consortiums together to adopt. I think the final thing is it's also going to be an opportunity. And the reason I say that is I think there's now a drive, and you talked about Elon Musk and all the things that he's trying to do, but we see a drive with the miners towards trying to be green and trying to assure that the technology is green. I believe it's something like 40% of crypto is already using green or clean energy as part of the mining process. And I actually think it can play a role, because of that additional demand and the fact they're willing to pay for it, to help to accelerate the development of clean energy technology. So I think it's both a challenge and an opportunity.
I agree. So what's the role of digital technology in creating transparency to optimize carbon footprint management across value chains? And can you maybe give me some examples of how things like open source standards and interfaces are enabling the energy transition?
Yeah, I mean, I think maybe I'll dwell a little bit on what we're trying to do with Open Footprint. And I say trying because it's early days, but I think, if you look at emissions monitoring, which is a big problem, both in terms of methane and in terms of CO2, today we really struggle to actually get a clear handle on what are the emissions everywhere, because that's ultimately the sort of problem that we're dealing with, as well as also making sure that those things are transparent, that the calculations are verified, and that we're all talking about the same thing. Because I think distrust enters the system quite often. If you have big companies, and you see it sometimes in the press, declaring these are my CO2 footprint, are you talking about scope 1, 2, 3 emissions? How are you verifying the calculation that you've done? Which regulatory body are you using? And so on and so forth. And so you end up having as much of a dialogue about the emissions as you do about the actual content of what you're trying to solve. And I think what we're trying to do is, through Open Footprint, to create that transparency. And you say, how does digital help? I think the great thing is, particularly with the advances in satellite technology, some of the things like the Tropomi satellite, which is a recent example, is starting to create the ability to track global methane emissions. I think those sorts of movements are going to create, if you like, global measurement capabilities, which can give you global transparency. And I think the opportunity on that is then to build open standards that take advantage of those things, and then to effectively accelerate that as a common baseline. And I think there's also going to be business opportunities in that, because of course, on top of that, you can do things like offsets, or you can do carbon capture and storage, and that potentially creates new business models as everyone becomes more conscious of their CO2 and methane footprints. And so, that's just one example, but I think it gives you an idea of how I see, if you like, open data, then open source, and then applications developing on top of that, which may result in new business models. But I do think that open data, open source is going to be the common foundation, and it's something we're pushing very hard. I mean, for example, I talked about Tropomi, but we've been working with Microsoft on a hackathon to try to demonstrate this, and then to try to catalyze investment in this space to accelerate the development of these sorts of technologies.
That's great. And I guess in order to achieve your own transformation, you need to address organizational culture. And I think there will be lots of people in Shell that have grown up in a world that was very different, where carbon was king, where profitability was king, where the external effect of some of the things that Shell was doing didn't really matter that much. How do you drive this cultural change and this transformation in Shell, and what have you been doing to help with this?
Well, I mean, I'm glad we got to this one, Bernard, because as you know, this is one of my favorite topics, and we've talked. And firstly, I also want to say thank you to you, because I think we talked a lot about this when we were putting together some of the strategy work. But I think the first thing I think, and this, is it starts with leadership. I'm going to do a shameless plug. If you didn't hear Elizabeth Brinton earlier on today talking to folks like Darryl Willis at Microsoft and also to SAP, I think check that out. That session, I think, gives you an idea of some of the the overall leadership that Elizabeth's bringing in this space, which has been fantastic. And I think I've been very fortunate to have that leadership support and sponsorship, both for the digital transformation and also for the shift that we want to make. And we put that all together in our Powering Progress strategy. So that strategy piece is absolutely fundamental. But I think it also, that's the top-down aspect, but we've also gone about this bottoms up. We have amazing people at Shell, and many of them want to make an impact. They want to drive this change. And so we've been looking at how can we empower the front line to help to accelerate, in particular, the digital transformation that we're going through. So we developed the Shell AI network. It started with about 30 people. It's now 5,000. And that's really people who have come together to share in the vision that AI technology can transform the way in which Shell does business. We're also rolling out DIY capabilities, so do-it-yourself capabilities, both in software development through things like Power Apps, but also through DIY data science using tools like Azure Machine Learning, which we're rolling out at the moment. And again, we've got over 1,000 people doing data science development across Shell using those DIY tool sets, and similar numbers doing DIY software development. And I think it is enabling that problem solving at scale through the frontline staff and empowering the organization with a clear vision. That's what I think is really going to drive it. I'll say one final thing, and I alluded to it in the keynote. Also, I think an attitude of openness across organizational boundaries, recognizing that the energy system has to come together and that no one company has all the answers. I think that's fundamental. And that's where open source comes in. We've also developed digital collaboration agreements with companies like Equinor, for example. And the idea being that actually that sectoral approach where you cut across organizational boundaries and drive things is really important. And the final thing I'll say is with our customers. We're working with companies like Dalmia Cement, who are a leading cement manufacturer in India, to try to partner. For those who've read Bill Gates's book, he always asks the "what about cement" problem, because actually, what about cement? You can't forget these heavy industrial sectors that also have to transform in order to mitigate some of the global impact of CO2. And so I think the key point is working with customers like Dalmia to bringing our energy expertise together with their process expertise to develop solutions. That's also going to be a key part of it. So cultural change at all levels, Bernard, which is somewhat challenging.
Absolutely. So we're talking about digital technology, but how is it actually enabling the next generation of clean energy technology? Do you have any examples that really illustrate why digital technology matters in this space?
Yeah, I mean, I probably didn't cover it sufficiently in the keynote, so maybe it's really good to unpack it. I think the one of the big opportunities, I think, is if you think about the grid or the industrial processes that we've had, they've developed over, in many cases, 100 years. So in many cases, you're dealing with a combination of new and old technology. And the big challenge we have is actually that most of that has got to be transitioned in one way, shape, or form over a period of time. And I think the reason it's taken so long is often the design process that we go through to develop these new technologies and then to deploy them and test them and so on is really challenging. It takes a long time to develop some of these new systems and then to get them embedded at scale. I think where digital technology can play, one of the areas that digital technology is going to play a key role is actually in helping to accelerate the development. So if you think of something like a digital twin, if you can create a digital twin of a design concept and you can then simulate every possible set of parameters, and then you can iterate on that and you can optimize, you can then start to very quickly zero in on the optimal design. And this isn't new. I mean, you see it in Formula One racing, in boat racing, in the things like America's Cup. There was a session on that earlier on in the conference. So these concepts aren't new, but to apply that technology to the energy sector, I think is absolutely fundamental. And it's not just AI, it's also things like computational fluid dynamics, high performance computing. It's going to take all of that to create these new energy concepts. And that's very much what we're focused on within my group, is trying to apply some of those fundamental technologies to some of those design processes to help to accelerate the transformation.
Yeah, you mentioned digital twins there. This is for me a fascinating technology that has so many applications in so many different industries. Do you have any real world examples of how Shell might be using digital twin technology?
Yeah, actually, I think it's been an amazing journey, the digital twin journey. We've been partnering with Kongsberg for some time now in the digital twin space, and the first deployment was at the Nyhamna gas plant. I'm afraid I don't have the statistics off the top of my head, but we've already demonstrated through that we can significantly reduce the energy footprint of the overall system, but also all sorts of other benefits that you get from that in terms of just process visibility, identifying anomalies, being able to understand what's happening, to do exception-based surveillance and so on. So we've got that running at scale. It's dealing with, hundreds of thousands of documents and bringing all of the PIDs together. We've put all of the time series data in from the historians and from the data capture system, and we've now got this integrated three-dimensional visual reality of the plant, which is just fantastic. And if you want to see it, there's some write-ups on the Shell website about it. But that's one real example, and I should say we're now rolling that out globally. So we've just gone live at Scotford and in Trinidad and Tobago, but we also want to take the same technology we've developed in our core business and apply it to some of the newer assets that we're developing and acquiring in the new energy sector. So I think what's great is the transferability of these sorts of capabilities is really exciting.
Very good. And so is digital twin technology now something that you would use routinely across the business for everything? And how far are you with this implementation?
I think, honestly, I think the deployment is real. It's real in a few assets. We have a plan to scale that over the coming years to full global scale. So really being everywhere. I think, as you know, Bernard, the embedment of this stuff takes time. It doesn't happen overnight. But at Nyhamna, it's been a real transformation in their ways of working, and they really are using this as part of the ways they do business every day. And so I think we'll see that over the coming years. And I think it will be that challenge of embedment that's going to dictate the pace. But I think what is exciting is that the pace is picking up. We really see digital twin technology starting to become mainstream now, and not just being a concept that we talk about.
Absolutely. There's so much more we could talk about. Our time is coming to an end now. Anyone listening, watching us, connect with Dan and I on social media, on LinkedIn, on Twitter. This area is so fascinating. There's so much more to learn. Join the discussion, and thank you very much.
Thanks, Bernard, and thanks so much for joining me.
My pleasure.
And thank you from CogX to both Dan and to Bernard for a fascinating, in-depth discussion. If you are with us online, please do stay on the Planet and Smart Cities channel. We are our next session actually it should be a fascinating one. It's called Winning Hearts and Minds, and it will be artists and collective intelligence designers talking about how we can envisage and also participate in our futures. That starts at 5 p.m. For those at the Everyman King's Cross who've been in this space, thank you very much for being my guests. I'm Joy Ladico from the Financial Times. That's the last session that's happening in this room, but there's still stuff going on around. The Lighterman is open for drinks afterwards. I'd also like to thank our partners again, who include Accenture, Quantum Black, Visa, and I've just forgotten the last one. Shell, thank you. For making this festival happen. It's been brilliant. Thanks ever so much, and see you all later for a drink.